Welcome to part 2 of this Altronics Universal Regulator kit build. In this video the focus shifts from preparation to final assembly. With all components now identified and ready to be positioned, it's time to solder each device onto the PCB. The sequence covers every part of the regulator circuit, the resistors already fitted in the previous step, the ceramic and electrolytic capacitors, the LM317 regulator IC, the header and jumper used for output configuration, and the PC pins that form the external connection points. Each component will be soldered cleanly and securely, ensuring solid electrical contact and long-term reliability. By the end of this stage, the board will be fully populated and electrically complete, ready for inspection and first power-up in the next part of the series. With the resistor bank now seated and trimmed, I move into the soldering stage. The iron is set to 360 degrees Celsius, which is a reliable working temperature for clean, controlled joints using resin core solder. Before touching any solder, I place the iron so it contacts both the pad and the resistor lead at the same time. This forms a proper heat bridge, ensuring the joint comes up to temperature evenly. Once the heat has transferred, I introduce a small amount of resin core solder to the opposite side of the joint. The solder should flow smoothly around the lead and wet the pad without any pressure or force. I let the solder do the work. If a joint takes on too much solder or forms a blob, I simply lay down a length of solder wick and let the copper braid pull away the excess. When I'm satisfied with the shape and finish of the joint, I move on to the next resistor and repeat the process. After all the joints are complete, I take a moment to inspect the entire row. I'm looking for bright, even fillets with no pits, voids, or cold joint texture. Once everything checks out, I finish by giving the PCB a light clean with isopropyl alcohol. This removes the residual flux and leaves the board looking sharp and professional, ready for the next stage of the build. With the resistor bank complete, I've gone ahead and mounted the remaining components off camera to save a bit of time. All the leads have been trimmed to a clean, workable length, and everything is now prepared for soldering. The iron is set once again to 360 degrees Celsius, the same temperature that delivered consistent results earlier. I'm using the exact same soldering technique demonstrated during the resistor stage, establishing a proper heat bridge, letting the joint come up to temperature, and feeding in just enough resin coarse solder for a clean, controlled fillet. Some of these components use larger diameter leads, and those joints naturally require a little more solder to achieve full wetting. The principle doesn't change. The solder should flow smoothly around the lead and bond to the pad without force, pressure, or hesitation. I work steadily across the board, watching each joint form and ensuring the solder wets correctly. Any sign of a dry or cold joint, a dull finish, uneven texture, or incomplete flow gets immediate attention and a quick reflow. High reliability is the goal here. Every joint needs to be electrically sound, mechanically secure, and visually clean. Once the last component is soldered, the board will be ready for inspection and the next stage of the build. Once all the components are soldered and I'm happy with the workmanship, I give the entire PCB a thorough clean using isopropyl alcohol. I scrub the board with a small brush to lift away flux residue, and for any stubborn buildup I use a bamboo skewer so I can break it loose without risking damage to the solder joints. After that, I continue washing with alcohol until the board is completely clean. When it's dry, I carry out a final inspection of every joint to make sure nothing needs rework. Fortunately, in this case, everything looks solid, so no touch-up is required. With all the soldering complete and the board fully cleaned and inspected, the build itself is now finished. The next step is electrical testing, and that will be the focus of part 3 in this series. I'll be using a bench power supply, an oscilloscope, and a multimeter to verify that each section of the circuit is performing exactly as it should. I hope to see you next time, and thanks for watching.